AGU Ocean Sciences Voyager Award. Ben completed his PhD at the University of Durham, which is one of the world's foremost centers of geological sea level research. And in 2004, he relocated to the US and went to the University of Pennsylvania, where he was an assistant and then an associate professor. And he's presently a full professor at Rutgers University, and he's also a visiting professor at the Earth Observatory of Singapore and the Division of Earth Sciences at Nanyang Technological University. Ben's research focuses on the mechanisms and nature of past sea level changes to understand how these processes will impact future coastal environments. And Ben's expertise in extracting very detailed reconstructions of coastal evolution from sediment cores and salt marshes and other coastal deposits has also led him to develop a sizable program in coastal hazards that draws upon the history of earthquakes and tsunamis and storms that are preserved from these records. Ben has rapidly distinguished himself as a leader both within and beyond his discipline. Certainly the impact of Ben's publication record alone would qualify him for this award. He's published over 140 articles in peer-reviewed journals, and as of last night, Google Scholar lists more than 4,000 citations to works that he has authored or co-authored. But aside from the impressive sheer number of publications and citations, he's also been recognized for the high quality of his research. He was a contributing author of the most recent IPCC report, and he has a growing list of honors, including being elected as a Fellow of the Geological Society of America last year. He also received the Medal for Research Excellence by the Commanding General of the North Atlantic Division of the U.S. Army Corps of Engineers, which is about the longest medal name I've ever heard, so it must be important. And he's also served on a number of expert panels both within the U.S. and abroad. So after hearing that impressive list of things, it may surprise you that in my letter of nomination for Ben, I actually didn't focus on any of those things because I didn't need to. His publication record really speaks for itself. And so instead, I focused my letter on talking about the many qualities that he exemplifies that speak to his promise for continued leadership in the ocean sciences, and I'd like to share some of those with you today. First of these is Ben's talent as an educator. He's built a highly successful research group and has done so at a really impressive speed. So he is presently supervising or has supervised 19 students to the degree of PhD and 7 postdoctoral fellows, and 10 of these people now hold academic positions. So there's no doubt that Ben has already had a significant impact on coastal sciences in the US by training future sea level scientists. And in fact, the case could easily be made that Ben has already had a larger impact in this respect than many of his peers achieved in their entire career. The other thing I wrote about is that Ben has developed a very strong network of interdisciplinary collaborators, including those who are at the very forefront of their respective disciplines. Ben is particularly effective in designing and implementing collaborative research programs that go well beyond his personal area of expertise and extend worldwide. And finally, Ben is a very talented public speaker. And despite his intense research activity, he somehow, and I'm not sure how, always manages to make time to devote to the important task of communicating climate change and sea level research to the public. And it's a role that admittedly not all scientists are willing to take on. And there are probably hundreds of examples I could list here, from the TEDx talk he did last year, to radio interviews, TV documentaries. I think he's a climate change movie star now, right? So the list goes on. So I'd like to conclude by saying that Ben has emerged as one of the most energetic and productive quaternary scientists of his generation. His accomplishments as a scholar, as an educator, and as a citizen of the ocean sciences community make him more than deserving to receive the Voyager Award. So please join me in congratulating Ben on his accomplishments.
Thank you, Andrea, for that citation. That meant a lot to me. And I'd like to thank, obviously, AGU and ocean scientists. I may as well stand up here so you can hear me better. So I'd like to thank Ocean Sciences for this award. I'm very honoured and I'm very humble, and although Andrew just said I'm a good public speaker, I'm very nervous about getting this award because I didn't really know what to say in response. I'm not a senior scientist, so I can't look back upon my career and say what worked and what didn't. And I'm not a junior scientist who has their whole career in front of them. So I didn't really know what to do, but I thought I'd just give a storyboard of my career and people that I'd like to thank. And the first person I'd like to thank is my undergraduate advisor, Andy Plater at the University of Liverpool. Andy saw something in me that nobody else saw. When I was an undergraduate, I wasn't the greatest academic. I had two loves at that time, and they were the same as the loves of the city of Liverpool, and that was music and soccer. But in my last year, Andy, who's in the centre, gave me a coring kit, and he said to me, "Go and call that estuary." And I was hooked, and I was fascinated. I was fascinated by the fact that as you push the core into the ground, you went further and further back into Earth's history. Now, I like this photo. This is a photo of myself, Andy Plater and Jerry Lloyd, who's a friend of mine, who's now a professor at Durham University. And it's a little bit staged, but I don't know whether you can see this at the back. But anyhow, Jerry's a very straight-laced individual, so he's reading the English dictionary. Andy Plater is a consummate professional, so he's reading a book on British wildflowers. And I'm reading some sport tabloid about some sex scandal involving Newcastle United soccer players. But Andy gave me the opportunity to pursue a PhD. And I pursued a PhD. My advisors were Anthony Long and Ian Shannon. Anthony Long taught me many things. First of all, the importance of looking after your field equipment and what happens to you if you lose your core barrel. But once I'd learned that lesson, Ian gave me great opportunities to experience a variety of field settings. This is some of the work that I did with Ian on isolation basins in northwest Scotland, where we're looking for signatures of meltwater pulses. So the aim of my thesis was really, the aim of it was to reconstruct sea level during the deglacial process. This slide here comes from my first PhD site. So it's on the northeast coast of England. We did a variety of coring behind a barrier spit. We're looking at the environment where we have intercalated clays and peats. Now, I'm a classically trained micropaleontologist, so we took this core, 95.3, the third core from my PhD. I looked at the pollen and the foraminifera to decipher the depositional environment, and I combined it with radiocarbon dates. And on the basis of that, I could produce some sea level data points. And we have a sea level curve from the northeast of England showing rapid rises in the early Holocene and stabilising. Now, as I said, I finished my PhD in 1998, and last week I got the approval for a paper for my thesis. So it only took me a mere 17 years to produce this particular paper. Which is rather hypocritical of me, because I tell my graduate students that you need to really publish very rapidly after you finish your thesis, not wait 17 years. But the reason why I'm still able to publish for my thesis is that I did something rather novel in my PhD. I took this sort of semi-quantitative data and I made it quantitative. And an ethos of my research is to always study the modern environment to reconstruct the past. And in the case of microfossils, what you do is you go out to a modern intertidal zone, you watch how the foraminifera in this case, or any microfossil, has biological turnover. So species A and B are in the high marsh, species C and D are in the low marsh, or species E within the tidal flat. So you empirically model that as a transfer function or a biotic index, and then you go to your fossil cores, and subtle changes in the relative abundance of these species are mirrored by subtle changes in relative sea level. So armed with this technique, I went abroad from the United Kingdom. And I was very fortunate to meet this guy, Steve Culver. He's obviously British because what other nationality goes to the field in a shirt, jacket and tie? But Steve opened many doors for me to begin my research in the United States and get a position at the University of Pennsylvania in 2004, from which I got tenure 6 years later. I was the first person in my department in 23 years to get tenure. And the reason for that's quite shocking, but the reason for that was because I had fantastic graduate students. It was a real honour for me to supervise these people. Two of them are shown here, Andy and Simon. But we also knew we were at exactly the right spots to study sea level on the Atlantic coast. I mean, you can find signs that tell you exactly where they are if you go on the streets in North Carolina. Now, Andy's research was based in North Carolina. He significantly improved the vertical precision of sea level, so we could get an uncertainty of around plus or minus 5 centimetres. And we really improved the chronology, perhaps by an order of magnitude or so we could get down to a decadal scale. So our research became policy relevant, and I got involved in climate science. And some of the work we show here, this is the last 500 years of sea level in North Carolina. You see sea level rising relatively slowly out of the Little Ice Age before increasing in its rate of rise in the 20th century. And we can say some rather powerful statements, working with a variety of statisticians, Neve Cahill, who's in the audience, Bob Kopp from my colleague now at Rutgers. We say things like, we can say it's extremely likely that the sea level rise that we experience in North Carolina of 2.6 millimetres per year is faster than anything that we see over the previous 2,200 years. Now, one of the things, and Andrea mentioned this, is that I look at a variety of processes that control sea level. So on the US Atlantic coast, I've looked at glacial-isostatic adjustment heavily, sediment compaction, tidal range, or climate-related sea level. But if you shift yourself to the west coast, it's tectonics that drive sea level. So the theory is that between earthquakes in the interseismic period, the plates lock, the overriding plates shorten, and the coastline will uplift, and that is basically gradual relative sea level fall. But when an earthquake happens, the land rapidly subsides, and you get a rapid sea level rise. And this is manifest in coastal sedimentary sequences. You can get a bury of a soil by an intertidal mud, perhaps accompanied by a tsunami. And you can see that in any of the bank sections along the from British Columbia going through to Northern California. So when I came to the US, I again made great colleagues. They afforded me some luxurious accommodation for my fieldwork. That's Brian Atwater's caravan that I stayed in. But more seriously, they gave me their time, effort and expertise. This is Brian Atwater showing me one of the most famous sequences of the AD 1700 earthquake with Andrea in Washington. This photo here is taken by Alan Nelson, showing another infamous sequence in Netarts Bay in Oregon. You can see here's 1700 earthquake, and you've got a variety of predecessors. When I came back to Penn, Alan said to me, someone's been there before. And he showed me a photo of Ian Shannon and Anthony Long coring the exact same sequence. It was slightly larger there. A series of geologists have been to the same area and excavated the same stratigraphical sequence. But what I did that was different is that I quantified the amount of subsidence associated with the earthquake. So we published quite a few papers recently, PhD students and postdocs. This is some of Simon Englehart's work in geology from 2013, where here we have the burial of a soil from the AD 1700 earthquake. The change in the microfossil species we can quantify as a subsidence of around 0.6 of a meters. Armed with this information, for the first time we can constrain a heterogeneous rupture for the Cascadia margin. So to orientate you, this is the Pacific coastline on its side. There's Northern California going through into Oregon, Washington, and British Columbia. And this heterogeneous rupture for the 1700 earthquake is akin to the 2011 Japan event or the 2004 Sumatran event. Now, I've also as well as looking at earthquakes, I've looked at tsunamis and storms. We've surveyed modern events, beginning with the Indian Ocean tsunami in 2004. This is one of our study sites, where you can see the power of that tsunami wave snapping these palm trees in situ. And this culminated more recently with us looking at the most powerful instrumental typhoon. There are two of my postdocs up at Rutgers, Nicole and Jessica. Now, the aim of this work is to provide modern analogues to reconstruct the past, because our instrumental record just simply isn't long enough to understand these rare but destructive events. And this is our most recent research. So this is from Tina Jura's PhD thesis. She sat in the audience. She's videoing me today, and she passed her PhD no more than 2 weeks ago. And in her thesis, what she uncovered in the central Chile coastline, which is the area of highest population density around Santiago, is evidence for large earthquakes, greater than magnitude 8.5, high tsunamis. You can see this by these sand layers that are unearthed in a coastal lagoon with an average recurrence interval of 500 years. So finally, when I told my dad that I was going to be an academic, he said to me, he warned me, he said, make sure, Ben, you don't go into academia with the aim of trying to be cited by somebody you've never met on the other side of the world. He said to me, there's got to be something more important in your career than that. And for me, that is outreach. We're now in the age of scientific communication, and it's also through education. I've had a fantastic time supervising graduate students, educating undergraduates, and every summer we take a 2-week residential to the marshes of the US Atlantic coast with some high school kids, and we try to educate them in science, climate, and the importance of our coastal wetlands. So to finish with, I'd like to thank again AGU Sciences. I'm really honoured and humbled. But I'd like to thank my dad. He has been my inspiration in my career. This is one of my favourite photos of my father. He signed a book commissioned by Charles II 350 years ago to be elected as a Fellow of the Royal Society. My dad's name is alongside Albert Einstein, Isaac Newton and Charles Darwin, amongst others. And that is an unbelievable inspiration to have as a dad. So I'd like to thank him, and I'd like to thank everyone else. Thank you for listening.